Good evening, everyone. Cool. Uh, Thank you for joining the session. My name is Pawan. I'm one of the principal serverless specialists, and here we're going to talk about, it's a core talk about the observability mystery using step functions. And I'm joined here by my colleague, Diego. Do you want to introduce yourself?
Yeah, my name is Diego. I'm a principal engineer on the AWS Step Functions team. Been working with Step Functions for a few years, and I'm very happy to be here with Pavan to talk about Step Functions and that tricky thing that to understand what's going on with my execution and where should I look at, mostly, and also talk about the new metrics that we just launched.
Amazing. How many of you are using Step Functions in production today? Just raise show of hands. Okay. How many of you have not used step functions at all? Okay, cool, nice. So yeah, in terms of the agenda, what it looks like, so we're going to start with like building something on step functions. So we will see like how do you start off, and then we're going to slightly increase the level, the complexity. Like we'll show about some of the observability, how do you actually debug it, talks about the important concepts that you would probably want to keep in mind while building these step functions in production. So with that, we'll get started. So we have 4 demos. So the first one, so this use case is around building or analyzing the wind speed data. So for this particular demo, we are actually going to use one of the open source data set for which actually shows what are the wind speed metrics is across the globe for each of the station. So let me quickly show the data set. So this is the data set that we're going to use, and as you see, it includes all of these parameters in here, like the mean temperature, dew point, sea level, and various other things. What we are interested is into looking at the wind speed data. The nice thing is it actually gives you this single line of command where you can actually copy this data set into an S3 bucket. In terms of what it looks like in the S3 bucket, let's open that up. So the data set itself is partitioned by year, and then it's also partitioned further into like the station ID. So you can see that it includes data all the way from 1929 and goes up to like 2024, 25. And if I open in one of these buckets or the into objects, like you can see these are the different station IDs, and the data inside that looks something like this. So let me zoom this up a bit. So you can see that it has the station ID and then the date parameter, the latitude, longitude, where exactly the station is, and we are interested in looking at these parameters. In terms of the end product, what it actually looks like is we have this particular dashboard which actually shows the mean wind speed across all of these different the stations across the globe. And if I click on one of these points, it's actually going to show where exactly it is also located. So let me try that again. So if I click on one of these points, it's going to show that this is located over here, and then also if I mouse over, it shows what is that mean average wind speed in that location as well. Cool. So with that in mind, let's go ahead and build this. Let's see how do you actually build this workflow. So step functions, go to the step functions console. Let's create a state machine. Let's give it a name called wind speed analysis. For this type, I'm going to choose the standard workflow. Now, for those who have actually not used step functions before, so for you to get started, the step function console actually gives you a very nice way to get started, right? Under the hood, it actually uses something called as the Amazon state language. So if you're new to it, like probably it might be a bit of a learning curve. So the console actually gives you a great place to get started with. So the first thing that you would do is drag and drop the map state here. Let's give it a name for this. Let's call it as dmap. And since we are working with the distributed map here, so what is distributed map? So distributed map is ideal for scenarios where you want to process large scale data. Like think in the order of like millions of objects that perhaps are there in S3 and then you want to process them. So the distributed map can really scale massively and then help in processing this data. The data set that you saw, the wind speed data, just to give you an idea, we have about close to 600,000 objects in the S3 bucket, close to about 70 GB of worth of data. So let's go ahead and click the processing mode. So there are two modes here. So either it can be like inline or distributed. So I'm going to choose distributed, and then you can pass in the the source. So either it can be passed in as an input, that's basically the state input that you see here, or in our case we are going to use S3. And then I have this drop down where I can choose which particular item source that I'm going to use. So this is really, this list has actually grown recently. So we introduced the Parquet format, the support for Athena data manifest as well. So in our case, I'm just going to choose the S3 object list, and I'm going to point it to the bucket where the data resides. So let's choose the bucket. And then the next configuration that I want to do is because the way how this processing works is it will pick up one object at a time, and that's probably may not be very efficient. It's recommended that you would enable the batching, and then you can say what's the batch size that you want to take these objects together and process them. So for this use case, let's give it as 500 objects at a time. You could either batch it by the number, or you can batch it by the maximum bytes per batch. The next is the concurrency limit. This is a powerful feature of the distributed map. So this basically tells, this is basically where it actually, the scale comes in, the scale of processing comes into play. So you can set the concurrency limit as 1,000 as a default, but it can actually go all the way to 10,000. So think of, your child workflow scaling concurrently 10,000 times, in terms of the concurrency size. So I'll leave it as 1,000. And then I can choose whether I want to use the standard execution or the express. So leave it as default. In terms of the additional parameters, I'm just going to set the tolerated failure threshold. So this is in case if my execution fails for whatever reason and that threshold crosses a 5%, then I want to deem it as the entire workflow to be failed. And finally, the last step is in terms of configuring the distributed map, I'm just going to say where should this particular processing output the data into. So I'm going to provide the S3 bucket for that as well. So let me choose the bucket, and then I'm going to prefix it with as demo. So that's in terms of the distributed map. Now let me configure, this is where basically I need to say, okay, what should happen inside the distributed map. So this is where my business logic comes into play. So in case of this wind speed, it's going to process that wind speed data set, right? So my Lambda function, which is already pre-created, what it actually does is goes into this individual data object and then looks up all the data and then calculates the mean average speed. It's a very simple Lambda function. So I'm going to choose the analysis Lambda function here. And then I'm going to also drag and drop another Lambda function. So think of this workflow as like a map reducer. The first Lambda function does the map processing. So I'm going to call it as analysis function. And the second one is going to be more of like a reducer. So once you have collected all the data, it's going to consolidate and generate the output. Let's choose the reducer function here. So that's pretty much it, in terms of what my distributed map looks like. Now, one of the other things that this data set actually has is, if you notice, all of these wind speed data is provided, the unit of measure is in knots. What if, I have a use case where I don't want it to be in knots, but convert it into maybe miles per hour. So I'm going to use another Lambda function which can help me out to do that. So convert to MPH. Let's have configure that Lambda function, and pretty much that's it. Now you might ask or wonder, like, do I need another Lambda function to do a convert here? Not necessary. The step functions also supports the JSON Nata, so you could pretty much use the math expression to do that. So you're already started thinking about, like, optimizing this particular workflow. So it doesn't necessarily have to be a Lambda function doing this. That's pretty much it, and then let's go ahead and create it. And if you see the screen, it actually prompts you with what the step functions or the state machine has identified as, based on the workflow it's defined, it needs the permissions and the policies set. So it's actually giving you that wizard that it's going to create all of these permissions for you. So let's go ahead and say confirm, and it's created the state machine. It's also, you can also go and look at the IAM permissions that it has created. Now let's go and execute this particular workflow. So in my case, I don't need to pass an input, but it's in case if your step function, so the distributed map needs an input, like, you can pass it in here to test it out. So I'm just going to click on start and wait for the execution. So now you can see the nice part about in the console, where you can see that it has actually started the map run state. So inside the map run, these are some of the observability things that is made visible to you to see that how the state machine is actually preparing your data set. So what you see here is in the pending state is the distributed map is actually reading or iterating over that list of objects in the S3 and preparing it for the execution. I also want you to keep an eye on this particular duration metrics to see how fast it actually takes to complete this entire execution of like 600,000 objects.
Yeah, one thing that you can see is that after we read all of your contents from your bucket, we start dispatching the executions. So the difference from the inline to the distributed map is that each iteration of your map becomes a new workflow execution. And this way you can parallelize higher than just having a contentious on one execution. And then you may face limits with the execution history and so on. So the distributed map gives you that option of each iteration of my map is its own execution with its own limits. And then here you can see that after it started dispatching the executions, it's moving over to the running, and then the executions are there on that list. And we keep track of how many are failing, because if you set tolerant threshold on failures, in this case was set to 5%, we abort executing, and then we fail the state. Also, you can also set a tolerance threshold on count. If you don't want to use percentage, you can say, if 100 fail, then I just want to abort it. So one part that it starts getting tricky is that everything that's happening here is asynchronous. And then customers ask us, it's very tricky to understand why some of my iterations are getting delayed to happen in the future.
Cool.
Yep.
Yeah, if you see that it's taken about roughly 2 minutes 15 seconds to complete all the executions, and each of these executions you can see that it has taken 500 items at a batch and process it. Now, if I go into the S3 bucket where we have the results, so you can look at the demo, and then in this execution you have the output, the CSV file that it has created. Now I can use the visualization tool like the QuickSight and show this on the screen. So this is how you can build a step functions distributed map to process large scale data.
Yeah, and if you were to have any failures, you would see a separate file here. With the one that says succeeded. And then that gives you the option to reprocess just the items that failed instead of reprocessing the entire thing. So you can even connect that specific file to another distributed map to redrive the ones that fail.
Before we move to the next topic, are there any questions? We can take maybe a couple of questions. Yeah?
So here actually you had set a limit of 1,000, right, for concurrency or something.
Yeah.
In that case, if all 1,000 lambdas, which is the limit actually given on AWS account, if it is all exhausted, like they even get an opportunity to run, or like will it be throttled, or what goes on there?
Yeah, so the question is, the default concurrency was set to 1,000, which is usually the default for the Lambda functions. So if that number was higher, would the Lambda functions even have the chance to run? Okay, so on step functions, when you configure your state, and then as you're doing the drag and drop in configuration, there's an option to handle failures. So you can catch throttling exceptions and retry with backoff, and then the workflow will take care of you of rerunning them. I believe there's a few exception types that you can catch from Lambda. But if you start more than what your downstream service can handle, usually they throttle you, and then you can catch and manage on your state machine.
And just another point on the Lambda concurrency limit, that limit is a soft limit to begin with. Like you can always open up a support case and it will be approved in a few minutes time. So it's not a hard limit as such. Cool. So we'll move on to the next one. So Diego, question to you. So now we have seen an example of the map run, right? What sort of like visibility or from an observability standpoint customers can use in order to get like more deeper insight?
Yeah, usually when you're investigating things that are asynchronous, you don't directly see failures because they're just running somewhere out there. And then after operating the service for some time, we noticed that would be great if we launch new metrics for our customers, and we did a few months ago. So now you can track the limit that you have applied on your account for the amount of open execution, open map runs that runs concurrently. We also publish how many you have approximate running at that specific point of time. And another one is backlog. So let's say we are trying to start more map runs, but because of your limit, we cannot start more. So one thing that's great about step functions is that it doesn't fail. So even if you're getting throttled, those things get scheduled to happen in the future. And as soon as something completes, the other one just takes the limit and it starts running again. But one thing that was tricky is how big is my backlog? Because I don't know how far are they along, or how longer do I need to complete all of them. And we recently launched those 3 metrics. And maybe you can show us how it looks like on the CloudWatch.
Yeah, so let me switch over to the demo. So while Diego was talking, what I did was I have another load test step functions here. So if I just quickly show you, so what it actually does is pretty much takes the input of from a CSV file, which has like a bunch of random numbers, and then it goes and calls this particular function, another state machine, which simulates the open map round count. So I have a dashboard here, and if I show you the metrics that we are monitoring. So these are the metrics that Diego was mentioning, which was recently launched. So you have the open map run limit, which is the maximum, and then you also have the current open map run count, which shows you the current status, and then you have the map run backlog size as well. So now, while the load test is going on, if you wait for a few seconds, we can actually see that the map run limit is exceeded, and then you'll start seeing the run backlog size started to increase.
The important thing about keeping track of your backlog is that you can even alarm yourself, because maybe you don't even know that this is happening. And what could happen as well is someone sharing the same account goes and deploys something that consumes the limits that's shared across accounts. And then you can identify, oh, this is happening, and then we need to identify what's going on and what should we stop, or maybe what should we talk to support and get higher limits. And this is where sometimes you can either just directly talk to support or go to service quotas and requesting limit increase, and then you can quickly recover from that state.
I think we've already seen it's actually exceeded. So if you see the dashboard over there, the widget, it's actually already exceeded the number of open map run count, and then you'll start seeing the map run backlog size started to build up. So as a best practice, like, this is something that you should probably set as a threshold and then generate an alarm for your team to, like, take an action or see what's going on.
Right, and keep in mind that metric is only published when there is a backlog. So if you don't have a backlog, you see no metric, but eventually when they happen, you start seeing the metrics. And if it's growing, you just see it keeps going up and up and up, and then when it starts draining, you see it going down. And eventually you'll see the no metric data again.
Okay, probably we'll take a question before we move. Yeah?
For a distributed map state that uses Lambda for processing, if you have like 600,000 files to process with that single Lambda, I think most accounts have like a limitation on asynchronous implications for Lambda. How does this get around that? Like, would it just run maps implications of that Lambda to process big catches?
Do you want to take that?
Yeah, so the question is, in this case, you had 600,000 files from S3, and then you pass it over to Lambda. How does Lambda handle that volume because the limit is 1,000? Did I get it right?
Yeah, limitation on limitation.
Okay, so what happens here is that the first thing we did was to set a batching. So the payload that you get on your Lambda function contains that batching, and then you can manage how big the batching is. And then on your Lambda function, you handle that. I believe the number was 500.
Yeah.
And then as you run your Lambda function, the invocations will be limited to the limits you have on that specific function you're calling. And then similar to the previous question, if the Lambda throttles you, you need to catch those errors and retry. And then you can manage the backoff for how long you want to retry. And then you can even set the jitter on the state. You're welcome.
Yeah, and just an extension on that point, like the example that we have on the Lambda function, right? It actually also calls the S3 APIs as well. So sometimes if you're exceeding those limits, like, you can get throttle exceptions on the S3 as well. There's a way to error handle it on the step functions itself, like, which is part of your state machine definition, and then you could also like have retry mechanisms as well. That's all built on the state machine definition. Yeah. Cool. So we've had a look at the open map run. So now there's another scenario that a lot of customers encounter or like, will have to keep in mind is the state transition. So Diego, what is state transition in this concept, and like what sort of behaviors would you encounter in step functions?
Yeah, so state transitions, you can assume is when the execution starts and when the execution completes, and when it goes from one node to the next one. And when you're talking about distributed map, is each iteration that started. So step functions by default, it has a limit of 5,000 per second on state transition. So let's say you started a number that's higher than that. Step functions gives you 5,000 per second, and when you try to run more than that is when you start getting throttled. Usually when it's an API call, you get the error immediately back, 429, throttling, too many exceptions. But again, this is an asynchronous process and you may not even see. Maybe someone went to the account and started consuming the state transitions. This is a shared limit. So you start getting throttled and start affecting the other state machines running on the same account. So on the example here, let's assume you have a bucket. Every single second, this bucket gets refilled. The default limit is 5,000 in large regions. And then every time there is a state transition happening, it consumes one from that bucket. So let's, in this case, for just to illustrate what's going on, let's say you started a huge load on step functions. Eventually, this bucket's going to be empty. You're going to get throttled. And the good part is that step function doesn't fail your executions. Those state transitions get pushed to happen in the future with a backoff. So let's say the first run after 1 second, and 2, and 4, and 8, and then it keeps increasing, and there is a limit. But then for you as an operator, you go and check your execution, and it looks like nothing happened for 30 seconds. So you may assume, oh, there's something going on. with my execution, maybe my code is wrong, maybe my definition, maybe I'm getting throttled somewhere. So as an operator, where should you check to understand if that's the case for you, if you're being affected by this? So maybe Pawan, we build something that can show that to us. Maybe you have a nice dashboard.
Cool. So I have an example where you can simulate the state transition. So by the way, all the samples that we are using here, we'll share it with you in case if you want to try it out, test it out. So towards the end, there's a link that we'll share where you can find all these demos. So yeah, this is a state machine that I have, which basically does loops within a loop, kind of to simulate the state transition. So it takes in like the past state and then has this parallel state, which calls the other choice state and goes on and on. Again, going back to my load test state machine, I have just initiated the load test on this specific workflow that I just showed. Now, if I go back into my dashboard, there is this metrics that's available in terms of the state transition quota. So let's just open this to see what are the things that we are monitoring. So as Diego mentioned, these metrics as the bucket size, the refill rate, the consumed capacity, and the throttle events, these are all available here. The best way to monitor some of these, for example, the bucket size, it's the maximum statistics that you can use. Same is the case with the refill rate, the max statistics, and then you have the consumed capacity, which can be a sum aggregation across a minute.
Yeah, one thing to keep in mind is that CloudWatch metrics, they are published by minute, but your limits are per second. So it's an average across all the seconds in a minute. So sometimes you see that you got throttled in a second, and then you see the data point, but then when you look at your limits, it may not correlate exactly to the second. It's just because the metrics are published every minute.
Yeah, so if you see the dashboard, it's already started showing up that there are some throttles that are happening, the state transitions. And if you want to find out which specific state machine perhaps was contributing to this, so let's go ahead and try and add this execution metrics. So what I did was selected execution throttle as my metrics, and then I'm going to choose all my state machines in my account just to see which one is actually causing the problem. And in terms of the statistics, let's choose sum and the period as 1 minute, and let's create it. So now it's created a dashboard for me, the widget for me, and in here I can mouse over, and then I can see which are the top two state machines which are actually contributed to the throttle. So one is the state transition as expected, which is contributing to the throttling here.
Yeah, and again, it's important to understand that your executions will not fail because you're getting throttled. They'll just be running somewhere in the future. And then if you encounter this situation, you can just go to service quotas and request an increase. And depending on the limit, it gets automatically approved, and then things will start moving faster, and then you recover.
Any questions? Anybody has any questions? Maybe we can take a couple of questions. Yeah?
So what's the unlimited versus software? You said 5,000 transactions. Is it per account or is it per second?
It's a soft limit. It's 5,000 per second in large regions. There's no hard limit. It's usually given and provided by use case. So you can just reach out and say, hey, I have this use case. I actually need, 30,000 per second. And then we discuss and decide what.
Is it per account or is it per?
It's per account.
Per account.
Yeah.
Yeah, so these.
More of the step function that you can get it much easier.
Sorry?
So if you get more of them running, you can get.
Yeah, you consume more state transitions across your account. That's right. And having a dashboard that filters out by state machine, it's easier to point it out which one is the one that's consuming the most. On this case, the limit is different per region. So large regions, 5,000. Smaller regions is 800. There are soft limits, and we can increase. And with this metric and dashboard, you can easily identify why your executions are being delayed for the case of a state transition throttling. But there's also another case that understanding what's going on behind the scenes can simplify the way you design your state machines. And in this case is when you have cross-account integrations. So let's say you're building your state machine, and then you go and invoke a nested state machine that belongs to another account. If the parent and the nested are in the same account, Step Functions create something called manage rules on Event Bridge, and then it listens for the events on the nested execution completion, and then automatically notifies the parent, completes, and move on. But if you're using cross-account, your state machine cannot read events from other accounts by itself. And the way it works is by polling the status of that execution that the parent started. So let's say you created a parent with a child, it's a cross-account, the Step Function is navigating through your state machine, it reaches a state that calls the start executions on a state machine in another account, and it's an asynchronous process. You just get a success response back saying, hey, I started, and then it's stuck there, right? It needs to wait for the child execution to complete. And then you're waiting, somehow the child completed, and your parent is still waiting for the completion. So what could be the reason why the parent didn't get notified from a cross-account invocation? I'll pass it over to Pavan that has an example of this happening, and then we can discuss about this.
So in terms of the setup to show you the demo of this particular scenario, so we have an account where you have a workflow that looks something like this, where an input, take for example the product review input, which has like the product ID, maybe a description of the product, and maybe a review of that particular product. So it goes through the workflow of like passing through a Bedrock API, which then analyzes it to see whether that particular review was actually a fake review or a real review. And then there is a choice state to say, okay, if it is a fake, then pass it on to another logic which will process it. If it is a real one, then you would just bypass it. So that's the workflow that you have in the central account. Now there comes maybe another team that would say, okay, rather than us building this particular workflow again in our own account, why don't we make use of like the cross-account invocations, like from create a parent workflow here, and then call the child workflow. So this is what you can, you can use a cross-account integrations here. Typically what you would use is the .sync method or run a job within the Step Functions naming that you would call this particular child workflow. Now there are a few things to keep in mind while you have this particular setup, right? Now first thing is like each of these state machine has its own role. Like the child function has its own role to call Bedrock APIs or maybe other AWS services in there, and your parent function has its own role. But also you need to establish a trust relationship between the cross-account calls. So what does that look like? So this is an example of what that trust policy will look like. Your parent would need the permissions to assume role on your child, the role on your second account, which is the child account role, and then on your the child account, you need to have a principal which will make sure that it's actually able to assume the role with the principal of your parent account, and then you're also passing this conditional attribute into that just to avoid or not run into the problem called as a confused deputy, where you're saying that only allow the assumption in case if it's coming from this particular account or from this particular state machine. So once you do that, you're establishing the trust relation. So this is how the setup looks like. So that's what I have in my account. So let me quickly jump to the demo and show you what it looks like. So in my parent account, I have this particular state machine, which is calling my, the child workflow that you see cross account. And while it's also passing, I'm just also using this target role ARN for the cross account invocation. In my child, I have this particular nested process review workflow.
And while things are loading, let me explain how it works behind the scenes on step functions. So we added support for cross-account a few years ago. And the way step function does it is through role chaining. So you have an execution role on your state machine that is used to run its own steps. But because we allow cross-account, that execution role can assume another role on another account. And the way you create the trust relationship between them, it's how Pavan created. So you go to the target role, which is the one that is used for chaining. And then you say, I trust that state machine that's going to making the call. And then as the execution is going through, it calls a SOM row on that. And with that credentials, it makes the API call. And this is not only for step functions in nesting. You can make cross-account on the other services as well, on the other integrations. Just make sure you set the target role, because that's what's going to be used for role chaining. And keep in mind that role chaining is not made by step functions. When the call happens, it's made by the source account. So you can have some controls on the relationship between them. And it's not step functions making a direct call, because maybe the target account doesn't even know that this is coming through step functions. And probably they shouldn't know how you architecture your application. They just receive a call from a role you trust.
Cool. So this is what my child workflow looks like. Again, the Bedrock API classifies the review and then passes it on. So let's call the parent workflow here. So let's go and pass in an input. So just for fun, let's give it as today's date timestamp just to validate. And if you see the payload, it basically has an ID, an overall review, a review text here, and a few other payload information in here. So let's go ahead and start this. And this is called the child workflow, and you don't see it yet completed. This is the problem that Diego was describing. And if I actually go into my child workflow, you can see that this particular workflow has received that input and it has completed that execution. And if you notice the payload, let's refresh it once again. If you see the payload, this is the ID that we passed in. And this is completed and this is succeeded. Whereas the parent one execution, it's if you refresh it, it is still showing in an execution state. So something's going on.
Another option is to just click on the execution link that you see, guys, if you scroll down. Yeah. There's an execution link that goes directly to the child execution that was started.
Yeah, I think there's sync permissions there.
Yeah, okay. Because it's cross-account, so in this case, you can't go to someone else. Yeah.
Yeah.
Yeah, but if it's on the same account, you can just click there and go to the execution to see, oh, it actually completed. So what's going on with my execution? It goes back to what I explained before. When it's in a different account, you call start, and that process starts somewhere else, but you don't get events happening from that account. The way it works is that you need to poll for the status. So it's very common that if you are in the situation and you are not very careful with how you set up the permissions and the relationship, behind the scenes, Step Function is trying to get the updates for those executions that happen in somebody else's account, but is getting access denied. So in this case, Pawan, how would you investigate this?
Maybe I'll ask a question to the audience, and maybe I'll take some help from the audience. Like, how would you troubleshoot this kind of a problem? Like, what tool or what services would you use?
Ask Cloud to go check CloudTrail.
CloudTrail? Okay. Does anybody agree or deny?
Yeah,
Okay,
go-
let's
go check out.
check CloudTrail. Yeah, that's a very good option. Okay, and let's maybe filter it by source, since it is state. And let's also filter in the last 30 minutes. And yeah, so you're right. So you do see that there are some access denied that's already showing up there. So if I click on this execution history,
It should be the describe execution.
sorry, yeah, the other one. Yeah, the describe execution.
So that's the describe state machine. It's probably easier if you scroll to the right and see the state access denied, and then you can also filter by event name, describe execution.
Yeah, let's do that.
And then you pick the access denied.
So, yeah. So if you notice this one, this was related to my execution, and you can clearly see that this particular role doesn't have the permissions to describe the execution. So in terms of like fixing this, let's go ahead and try and fix that.
And in the meantime, what's going on step functions is that for the first 10 minutes, it pauses every minute, and after it adds a back off. So let's say you're on this situation, things won't fail. So as soon as you update your IAM roles and permissions and relationship, if something is wrong, eventually they'll just recover and succeed.
Does it pull only if it's cross account, or does it also pull if you do an execution in the same account?
It also pulls if it's the same account, but because it's the same account, events from Event Bridge is just faster.
Oh, okay.
Yeah, so it rarely completes through the poll, but as Werner always says,
Minimum waiting.
yeah, as Werner always says, things fails all the time. So if the event for some reason is not delivered, some reason is lost on the network, the poller is your backup. And
So it's event driven with a backup poll.
yeah, exactly. If it's a way to make it more reliable, because we don't want to fail if the child succeeded. So the way we do is to poll just for guarantees. So the parent waits. So the question was, it doesn't fail the execution, it keeps polling?
Yeah, because it actually succeeded. Right? The execution has some the state has.
Yeah, that's right. So the parent is still waiting for the completion of the child execution, but the child completed a few minutes ago.
Yeah, so when you say back off, it's like just hitting the state as it keeps polling?
Yes, exactly, because it needs to know what happened. So if you don't have permission to check somebody else's account, you can access that information. And the way it works is by the role chaining it needs the describe execution permission, so it can get what happened and then complete your own state and move on.
Then we will take the timeout after some time to go reset it. Because we fail it at some point of time, we're not ready to do it.
You put a timer on it.
Yeah, one option is to put the timeout. Yeah.
Yeah.
Will back off though.
Yeah, but then it's gonna fail eventually and move on, right?
So if you see the role permissions on this particular child role, right now it only has a start execution. So what we need to do is we add the describe execution as well as a stop execution. So let's go ahead and add those permissions in.
Another one that's important for nesting and cross account is the stop execution as well, if you want the parent to stop the child execution if the parent fails. So what happens is you have your parent running, starts a child, the child is running, and let's say you want to abort the parent. So what step function does is a best effort to stop the execution as well. But if it doesn't have permission to stop the execution of the child, the child execution, then it just moves on. So then you can see the access denied on CloudTrail as well, if that's the case.
So it will exactly ask for the specific step function run because you're using the describe only. You don't need the list.
Yeah, you don't need the list. It's only the describe because you need to know what the output is. Yeah, that's right. Yeah, the question was you don't need the list permissions, just the describe. Yeah. And the describe is the one that provides your input and output and the state.
All right, let's add the stop and describe policy. So that's in here on that specific execution related to my demo nested workflow. And let's go ahead and give it another try now. Okay, let's copy. Let's give the overall as 4 and then start the execution.
So you need that. So this is only a call method. So there is no push from the nested function on the dedicated account.
The question is, for cross account, it's only polling. Yeah, that's right. If it's the same account, then the events get notified through the manage rule that's created on Event Bridge. And Event Bridge sends those events to step functions, and step functions identifies the event, and then, oh, this is for that execution that's waiting, and then completes that task and move on.
It's interesting that you have, the previous ones are now succeeding.
Exactly. Yeah, exactly. Yeah.
So that's because on the next run, because we back off, on the next run, we try to get new credentials to Paul, and then we call the describe execution. This time it succeeded, so we can complete the parents that were waiting, and then it just moves on.
So yeah, all the previous running states have all completed now.
So who do we talk to make him pull a little bit faster for a few 1 minute for the first pull is kind of high.
Yeah, you can always reach out to us, and we can customize.
Like, 10 seconds, then back up to 30, then do a minute or something like that.
Yeah. Usually when those things run too fast, let's say you started tens of thousands of executions, if they're all trying to poll, you may get throttled. So those things have to follow also a limit increase for the pollers. And this is what we discussed. The resolution on this case is because the parent workflow is trying to poll for the status to understand what's going on with the child execution. And this is because it's a cross account, you cannot read events from somebody else for security reasons. And what step function does is, hey, I need permissions to read information from the other account. And by doing the role chaining, I'm going to assume a role using your credentials for that account. And with the credentials from the chaining, I'm going to call the describe execution API. And after we fixed and updated the permissions, on the next run, on the next check, it will just succeed, it will complete, and then it will just move on. So here on these permissions, you can see the required for nesting is describe and stop. And the stop is if you want child executions to be terminated when the parent execution is aborted or fails. Let's say the parent execution timed out. You don't want the child executions to keep running. Maybe there's a use case that you want to keep them running and succeed. But in case if you don't, you can just add the permission to stop, and step functions is going to make a best effort to stop them. On the events part is because there's a feature from Event Bridge called manage rules. And the step functions create a manage rule to read events from your account. And then those events get delivered, and step functions know exactly how to route them, and complete the parent executions and with a specific task that's waiting. And if you don't have those permissions, the create state machine with a .sync integration is going to fail because we can't create the manage rule on your behalf.
Does it support like wait for task token? Because that might be a way that you could not have to pull.
Yeah, the question is, does it support wait for task token? It does. So you can control yourself. You can get a token and get it delivered, and then somewhere else,
Yeah, the final state of
yes,
child execution
can call it back.
You can do that,
You
Yeah.
didn't want to wait.
Yeah, that's right. But sometimes you can't modify the child, so you can't add this extra step. But if you can, this is a faster way of completing. You just need to make sure you have the right permissions because it will be a cross account. So you need to assume a role on that account and call this CentOS success in this case. Or CentOS failure if it failed. But then it's not a managed integration cross account anymore. And yeah, you have to do it. Any other questions on this?
Cool. So yeah, just to conclude, all the demos that we have done in the session, you can find it on that GitHub link. So you can scan this QR code. It will take you straight into that GitHub page. Yeah, and you can try it out in your own account and test it out. There's also a link to the compute blog post. So this is where we would publish anything about step functions, the new releases, launches, some of the best practices, how do you do things at scale and things like that. So all of those will be published under the compute blog.
Yeah. And for example, if you want to run even faster, you can just either increase the batch size or give it more concurrency. Just be aware that if you get throttled, things may get delayed, and then you need to request a limit increase. But those metrics that we launched recently for distributed map, they do help on these cases that you can just see what's going on and see, oh, I really have a backlog here. I need to handle that.